do numbers 6 through 9 in this recording. So in this one over here, we are adding vectors again. So we are given that we are going 5 blocks up north, that's 5, and then 5 blocks east, and then we are going 2 blocks north. And we want to know the displacement from start to finish. So if we drew it, it would be a vector going from where we started all the way up here to where we ended. So to find this resultant, we need to know the x and the y components. So from this one, you don't really have to write it all out like this, separating the x and y. You can if you want to, but you can already see it from the picture here that we only had to go 5 to the right to get to where we went. So that means that our x is 5. And then to get to where we ended up, we had to go up 5 and then up 2 more to get up here. So the y component is 7. And that forms our triangle right here. If I do a triangle, this is 5 and this one over here is 7. And if I use the Pythagorean theorem with this 5 and this 7, it will give me the magnitude of the resultant here. So r is just going to be square root of rx squared plus ry squared. And I got about 8.6. Now if you didn't like that, you can still do this problem the same way that we've been doing. So you can call these vectors, we'll call this one vector A and vector B, and then the third one vector C. So you can still find AX, BX, CX, AY, BY, CY. AX is 0. AX is 0 because it's vertical. The y component is 5. BX is 5. The y component is 0. CX is 0 and the y component is 2. And then you can see that when you add these up, you get 5 over here for Rx, and you get 7 over here for Ry. Number 7, finding the components of a vector here. The vector has a magnitude of 110 newtons, and it's at an angle of 30 degrees. So the x component is down here, and the y component is up here. So the x component is adjacent to the angle, so it's going to use the cosine 110 cosine 30, and the y component is opposite, it's going to use sine, so 110 sine. And that will give us answer C over here. You might want to memorize that sine of 30 degrees is equal to 1/2, because that will save you a lot of time when you're doing calculations. Let's do numbers 8 and 9. So the trajectory of the projectile, you have the least speed at the highest point in the flight. So this is because if you go ahead and draw this out, the projectile is launched at this angle, and then it's gonna come back down. So at the peak here, we know that it only has a horizontal component to the velocity. So everywhere else, the velocity has an x and a y direction. So at the top is where the velocity must be the smallest possible because it only has that x component. Keep in mind that the x component of the velocity anywhere in the path is always the same. But everywhere else besides the top, it has an x and a y, which makes it greater than just having that x component. And number 9, the acceleration is always constant. It's always negative 9.8 meters per second squared. Acceleration is always downward, no matter where in the path you are looking.